This lecture is a continuation of dual converter. A dual converter consists of two fully controlled converters which is connected in anti-parallel. There are single phase dual converters are there, three phase dual converters are there. In single phase dual converter, there are two single phase fully controlled converters are connected in anti-parallel. In three phase dual converter, two three phase fully controlled converters are connected in anti-parallel across the load. With the help of the dual converter, we can obtain four quadrant of operation. There are two mode of operation for a dual converter, that is non-circulating mode of operation and circulating mode of operation. In non-circulating mode of operation, either converter operate at a time, either converter 1 or converter 2 operate at a time. After the operation of converter 1, we will give a time delay of 10 to 20 milliseconds. After that, we will turn on converter 2 in order to ensure avoid the effect of circulating current in the converter. Okay. Next, we will discuss about the four quadrant operation of a non-circulating dual converter. Non-circulating current mode of operation of a dual converter. In non-circulating mode of operation, either converter 1 or converter 2 operate at a time. If converter 1 operate, assume that converter 1 is in operating condition. That means we are varying the firing angle of converter 1 from 0 to 180 degree. If firing angle of converter 1 varies from 0 to 90 degree, the output voltage is positive and output current is positive, and we can obtain first quadrant of operation. That operation is known as forward motoring operation. If the firing angle of converter 1 is varied from 90 degree to 180 degree, then we can obtain the output voltage is negative and output current is positive. Therefore, the output power is negative. So, the operation is the fourth quadrant operation, that is the inverter mode of operation. It is also known as regenerative braking operation of a dual converter. Okay. If converter 1 operates, we can obtain first and fourth quadrant operation. If converter 2 operates, we can obtain second and third quadrant operation. If we are assuming the converter 2 is in operating condition, if we vary the firing angle from 0 to 90 degree, both the output voltage and currents are negative. So, we can obtain rectification mode of operation. The output power is positive. So, the operation is known as reverse motoring operation. Okay, if we vary the firing angle of converter 2 from 90 degree to 180 degree, we get inverter mode of operation, and this is also known as regenerative braking mode of operation. That is the second quadrant operation of a dual converter. This is the fourth quadrant operation of a non-circulating mode of operation of a dual converter. In non-circulating mode of operation, either converter A or converter B operate at a time. Okay. Now we will discuss about the circulating mode of operation of dual converter. In circulating mode of operation, converter 1 and converter 2 operate simultaneously. If converter 1 operates in rectification mode, automatically converter 2 operates in its inverter mode of operation. The inductor, there are two inductors connected in series with the output of the converter 1 and converter 2. The main purpose of the inductor is to limit the circulating current. Okay, the relationship between firing angle of converter 1 and converter 2 is alpha 1 plus alpha 2 equal to 180 degree. Okay. Then, for obtaining first and fourth quadrant of operation, we are controlling the firing angle of converter 1. If converter 1 acts as a rectifier, then we can obtain first quadrant operation. If converter 1 acts as inverter or its firing angle vary from 90 to 180 degree, we can obtain fourth quadrant of operation. Okay, if converted to act as a rectifier, we can obtain third quadrant of operation, and converted to act as a inverter, that is firing angle of converted to varies from 90 to 180 degree, we can obtain second quadrant of operation. In order to obtain first and fourth quadrant of operation, we are controlling the firing angle of converter 1 only. Then according to the variation in firing angle of converter 1, automatically the firing angle of converter 2 varies. To obtain 1 and 2 operation, we are controlling the converter 1 firing angle. For obtaining second and third quadrant operation, we are controlling the firing angle of converter 2. Okay. Now we will discuss about the working of a three-phase dual converter with its output waveforms. Okay, this is the relationship between alpha 1 and alpha 2. This is discussed in previous lecture. Okay. Now we will discuss about the circulating mode of operation of a single phase dual converter. Here the input is a single phase input, single phase AC input, V is equal to Vm sin omega t. The output voltage of, we are considering the converter 1 act as a rectifier and converter 2 act as a inverter. Then the output voltage of V01. Converter 1 is acting as a rectifier, therefore firing angle is less than 90 degree. Alpha 1 is less than 90 degree. Thus, this is the output waveform of a, we are assuming an inductive RL load. So this is the output voltage waveform. Okay. Now the output voltage waveform of converter 2. Converter 2 acts as an inverter. Therefore, the output voltage of a converter 2 is in its inversion mode. Okay. Converter 2 is in inversion mode of operation. Therefore, this is the output voltage waveform of converter 2. For the converter 1, the firing angle is less than 90 degree. So, this is the output voltage. For converter 2, the firing angle is greater than 90 degree. The firing angle is alpha 2. Firing angle alpha 2 is greater than 90 degree, and similarly, output voltage is greater than 90 degree, and similarly it is an inversion mode of operation. The fully controlled converter is connected in anti-parallel. Converter 2 is connected in anti-parallel with the converter 1. Therefore, the waveform is opposite. Output voltage waveform is in inverted form. Okay, it is in the inverted form. Then the output voltage is the sum of V01 and V02. V01 and V02. V01 minus V02 is coming across the load, and this voltage will cause some circulating current, and the effect of the circulating current is nullified with the help of this inductors. Okay. This is the input voltage waveform Vm sin omega t. This is the output voltage V0. Output voltage of converter 1, which is firing angle less than 90 degree. Then the converter 2 acts as an inverter, that is the connection is in inversion mode. Therefore, the output voltage also is in the inversion mode. The firing angle is alpha. Alpha 2 is greater than 90 degree. Here the alpha 2 is greater than 90 degree, and it is in the inversion mode. Okay. Now we will discuss about the working of a three-phase dual converter with its output voltage waveforms. A three-phase dual converter also consists of two three-phase fully controlled converter. The output voltage of first converter is V01 and second converter is V02. Here we are assuming that the firing angle of V01 is equal to 60 degree, that is the converter 1 acts as a rectifier and converter 2 acts as a inverter. When the converter 1 firing angle alpha 1 is equal to 60 degree, then what is the firing angle of converter 2? Firing angle of converter 2 alpha 2 is equal to 180 minus alpha 1, that is 180 minus 60 degree, that is equal to alpha 2 equal to 120 degree. Okay. Now draw the waveform of the three-phase fully controlled converter when firing angle alpha 1 is equal to 60 degree. When firing angle alpha 1 is equal to 60 degree, at this instant, this is the firing angle alpha is equal to 60 degree. This is the firing angle alpha equal to 60 degree. This instant, the output voltage V01 traces VAB. Output voltage traces VAB. Okay. Then this is the output voltage waveform. VAB, VAC, VBC, VBA, VCA, and so on. This is the firing angle alpha is equal to 60 degree waveform. Then the output voltage of converter 2, the firing angle is 120, firing angle is 120 degree. Actually, the output voltage is in the negative side. That is, this is the 120 instant. Alpha 1 is equal to 120 instant. Therefore, at this particular instant, the output voltage V02 traces the voltage VAB. At this instant it traces VAB. Here it is VAB. This is VAB. Then at this instant VAC. At this instant VBC, and so on. Okay, but here our rectifier acts as an inverter, so we will draw V02 in positive side. Okay, here V02 in positive side, that is, actually V02 is in the negative side, but we are placing it in the positive side. Therefore, the current waveform looks like this. Okay, output voltage waveform of converter in positive side looks like this. Okay. Then the output voltage. What is the output voltage? Load voltage. Output voltage. Load voltage is equal to. Load voltage is the average of V01 and V02. Load voltage is the average of V01 and V02, that is V01 plus V02 divided by 2. Here V01 plus V02 is equal to V01 divided by 2. We get a particular voltage at this particular instant. So we can trace the output load voltage like this. Load voltage is positive. Okay. Then VR is the voltage across the reactors or inductor. VR is the voltage across the inductor, that is equal to V01 minus V02. VR equal to V01 minus V02. At omega t equal to 0 instant, V01 is a value and V02 is equal to 0. Therefore, VR is equal to V01 minus V02 is equal to V01. Okay, similarly we can trace the VR at this particular instant. V01 is equal to 0, V02 is equal to a value, therefore V01 minus V02 is a negative value, minus V01. Okay, similarly we can draw the reactor voltage. Okay, this is the voltage waveform of circulating current. IC is the voltage waveform of circulating current. Due to this difference in the voltage, that is a circulating current, and load current, we are assuming that load current is continuous. Okay, the main advantage of a circulating current mode of operation is the current output load current and output load current is continuous. There is no delay in the operation of dual converter if it operating in circulating mode of operation. The main drawback is due to the presence of the reactor or the inductor, the size of the dual circulating mode of operation of dual converter is very much higher, and size and weight of the circulating current mode of operation of dual converter, when dual converter is operating in circulating mode of operation, the size is heavier because of the presence of this inductor. Okay, this is about the dual converter. Okay, thank you.